Hello, welcome to week 12, lesson 3 of grade 7, Algebra 1. So today's lesson will be analyzing a verbal description of models. And functions. So example 1, Gregory plans to purchase a video game player. He has $500 in his savings account and plans to save $20 per week from his allowance until he has enough money to buy the player. He needs to figure out how long it will take. What type of function should he use to model this problem? Justify your answer mathematically. So it's obviously linear because he's increasing at a constant rate, $20 per week. That doesn't change. So and his initial amount at week 0 is 500. So this would model, be linear. Number 2. One of the highlights in a car show event is a car driving up a ramp and flying over approximately 5 cars placed end to end. The ramp is 8 feet at its highest point, and there's an upwards speed of 88 feet per second before it leaves the top of the ramp. What type of function can best model the height, h in feet of the car, t seconds after leaving the end of the ramp? Justify your answer mathematically. So here it's a quadratic function because you can imagine that the height will look like this, and when it leaves to when it'll go back to the same height, and it'll show, and the graph will be parabolic. So that's how you can know it's quadratic. And also there's other ways to know, but I think that's beyond I don't think that's required for this course, but you could tell that that the height changes. The height has a square relationship. The velocity is constant, or the velocity is linear, and you know that quadratic functions that model situations with height of a projectile in motion are taken this form: negative 16t squared plus v naught t plus h naught, which basically means this is the initial velocity and this is the initial height. The initial velocity is 88 and the initial height is 8. Okay, so number 3, Margie just got $1,000 from her grandmother to start her college fund. She's opening a new savings account and finds out that her bank offers a 2% annual interest, compounded monthly. What type of function would best represent the amount of money in Margie's account? Justify your answer mathematically. Okay, so we know that this is the form for compound interest. I'm going to explain to you so that you don't have to memorize these formulas, because you're taking up storage in your brain without truly understanding where they come from. So you have $1,000, that's the initial amount. You're multiplying that by a rate, by something. You're multiplying it by the interest rate. So here, this inside part is what most people hate memorizing. I'll tell you how not to memorize it. Hopefully this will help you understand it. You have 1, right? That's the initial value. If the rate was 0 right here, then you just be multiplying the initial value by 1. There's no interest, 0 interest. You're just getting the same amount. It's 1,000. Here there's a rate. It says that there's 2% annual interest rate so that means that every year, after 1 year, you get a 2% interest rate, which means that the amount of money you started with increases by 2% every year. But it's compounded monthly, which means every month you're getting that rate. So how do you find out how much you're getting every month? Well, you divide the rate over 1 year by 12, because there's 12 months, and that'll give you what percentage increase you're getting every month. So it'd be 0.02, which is the annual rate, divided by 12 months, and then you add that to 1 to get your monthly compound rate, your monthly interest rate. But you have to raise it so for 1 year, you'd raise it to the 12th power, because you're multiplying that rate 12 times for each month. Does that make sense? So that's where that formula comes from. If you guys understood that, then you won't have to memorize this, because I promise you it'll come up again. Unless they change the curriculum or something. Anyway, so it's an exponential. It's a type of exponential function. Okay. So, exercise 1. So, problem 1 of the exercises. City workers record the number of squirrels. City workers record the number of squirrels in a park over a period of time. At the first count, there were 15 pairs of male and female squirrels, 30 total. After 6 months, the city workers recorded a total of 60 squirrels. After a year, which is 6 more months, they were 120. So you notice that the number of squirrels, total squirrels, is doubling every 6 months. Right, so what type of function can best model the population of squirrels recorded over a period of time, assuming the same growth rate and no squirrels die? What function? Exponential. Write a function that describes the population recorded over X number of years. So we have the population with respect to X equals the starting number 30 times the rate at which they increase, which is double every 6 months. So every 6 months they double, which means that they double, right, twice a year. So in 1 year, they double twice. So X would be the number of years. So if you want to know the population after 1 year, you put in 1, and it would be this. You notice, so after 1 year, the population would have doubled twice. So after 6 months, it's 30 times 2, which is 60. And then you multiply that after 6 months later by 2, that's 120. That's why it looks like that. And there are other ways you could do it by doing this. You can write it like this, by X, or by T, and saying T is equal to the number of 6 month periods. So in 1 year, you just put in 2, it's the same thing. Okay. So a rectangular photograph measuring 8 inches by 10 inches is surrounded by a frame with a uniform width X. So it looks something like this. And so on and so forth. This is X, this is X, this is X, this is X. This is 8, this is 10. Okay. What type of function can represent the area of the picture and the frame in terms of X, the unknown frame's width? Picture, so here, well, if the picture, so it's surrounded by a frame. So let me redraw this. So you have the frame, this right here is 10, this right here is 8, and this is X. This is X. Okay, so to represent the area of the frame and the picture, the area would be, it would be, what is that, 10 plus 2x times 8 plus 2x, right? Because we want the length, we want this side, which is 10 plus x is plus 2x, and then you want this side of this side length, which is 8 plus x, 8 plus 2x. So Explain mathematically how I know. Well, I know that to find the area of a rectangle, I need this base times height, and yeah, that's pretty much it. I mean, write an equation in standard form representing the area of the picture and the frame in standard form. So all that's asking me to do is to just FOIL this out or multiply it out. And I'm going to show you guys something interesting here. Because this is the last week, I'm going to show you guys, maybe you guys didn't know this, maybe you did, but here's why. They tell you to use FOIL because it's quicker than doing this for most people. But here's where it comes from. It's the same thing as the distributive property. So I want you guys to imagine you take this right here, and you're going to multiply it by this, and then add the product of this, with 2x. So it's really like this. That's where FOIL comes from. And you notice, since these are the same, you could factor it out, and you're left with 8 plus 2x times 10x plus 2x. That's where FOIL comes from. And if you don't believe me, is equal to and that's the same thing if you use FOIL. 80 plus 20x plus 16x plus 4x squared. So that would be in standard form. There you guys go, that's where FOIL comes from. It's the same thing as the distributive property. You're just taking one of the terms, distributing it into the others, into the other two terms. So a ball is tossed up in the air at an initial rate of 50 feet per second from 5 feet off the ground. What type of function models the height? It's a quadratic. So, explain what is happening to the height of the ball as it travels over a period of time. Height increases, reaches a maximum, right? It reaches a maximum height at the top, then decreases. So C, what function models the height? So the height with respect to time over time is negative 16t squared. This is just an approximation. This is actually the approximation of gravity, acceleration due to gravity, in which is negative 32 feet per second squared in feet. But so that's why they have negative 16 if you're curious. Because if you take the derivatives to get acceleration, take two derivatives, you'll basically get the acceleration due to gravity, which is what that's supposed to represent. So that's why it's not random that they picked that. I didn't know that in 7th grade, but my teacher didn't tell me. But I learned it, I figured it out after. Okay, anyway, so okay. What function models the height? So we're gonna add the initial velocity 50t, because it changes with respect to time also. And then we're gonna add 5. So you're really adding the acceleration plus the velocity at that time plus the initial height, which is interesting. So, cool. For a population of insects is known to triple in size every month. At the beginning of the scientific research, there were 200 insects. What type of function models the population of insects after t years? Exponential. B, write a function that models the population growth of the insects after t years. population with respect to t equals the initial, which is 200 insects, times 3, the rate at which it increases every t years, but it increases every month. So every year it actually increases 12 times. So here you have the number of years. After 1 year it increases 12 times. After 2 years it increases 24 times, because every month it increases. There's 12 months in a year, therefore it increases 12 times every year. So let's see. So now, so problem set 1. The cost to purchase school spirit posters are as follows: 2 posters for $5, 4 posters for $9, 6 posters for $13, 8 posters for $17, and so on. So let's see. The cost. What type of function would best represent the cost of the total number of posters purchased? So we see every time you purchase 2 more posters, you're paying $4 more. So for 2 you get 5. Add 2 posters for 4. It's 4 posters. You pay 9, 6, 13, so on and so forth. So linear model. Now, part B. What function represents the cost of the total number of posters purchased? How did you know? Justify your reasoning. Okay, well, so I'm going to have the cost with respect to n, the number of posters, equals, well, the initial, if I subtract 2, the initial is 0. So 4 over 2 is 2, and so the cost, 2 posters for 5, 4 posters for 9, 4 divided by 2 more increases by 4. So each one costs 2, right? And I want to add 1. So for 2 posters, I'm paying 5. For 4 posters, I'm paying 9. For 8, I'm paying 17. That's the model. Because if I want to know how much each one costs, if 2 of them cost $4, 1 of them costs 2. It's that, and it starts. So for 2 posters, you're paying 5, but each one's worth 2, which means there was an initial cost of 1. C. If you have $40 to spend, write an inequality to find the maximum number of posters you could buy. So the maximum number of posters I could buy, right? Because the cost is a maximum of 40. I don't know if they want me to solve for that. Or... Yeah, they just said right, so. I'll be right here. NYC Sports Gym has 425 members in 2011. Based on statistics, the total number of memberships increases by 2% annually. What type of function models the total number of memberships in this situation? So, 425. It increases annually. What type of function? Exponential. Let's see. I don't know why they write it as 1 plus, but maybe they should. And then, if the trend continues, what function represents the total in n years? How do you know? Well, because each year, this is the starting amount, and each year it increases by a certain fixed rate percentage. Okay, that's how I know. So, three. Derek throws a baseball upward from an initial height of 3. The baseball hits the ground after 2 seconds. What was the initial velocity? Okay, so basically the acceleration doesn't change. The height function is negative 16 t squared plus the initial velocity, which we don't know, times t plus the initial height of 3. Well, I know that after 2 seconds it hits the ground, so the height is from initial height of 3. It's the ground, so that means that it would be at 0 after 2 seconds. So 4 times negative 16 is negative 64. I'm going to add it to here, and then I'm going to subtract 3 and 2 v naught, negative 61, 2 v naught. V naught equals 30.5 feet per second. I believe that's correct. Initial velocity, yeah. So you're assuming that the 0 point is the ground. Well, you're not assuming, it's telling you that, because if the initial height is 3 and you added 3, so at h of 0 equals 3, that means that it's 3 above the ground. So you're not assuming. What is the function that models the height over of the baseball over? Didn't I just write that? So v h of t. Well, now I need to write it with the missing variable, which was missing. Okay. At what time did the baseball reach its maximum height? So at its maximum height, so you know it's going to take a shape like this. Whatever, like this. Its maximum height is right here. And that's what we like to call the vertex. So here we have to find the vertex, which, so you can use it using this method. So to find the vertex, we can write it in vertex form. I want to, I don't know if I'm allowed to graph it or not. Well, see, unfortunately my graphing calculator is not with me right now. But if I'm not allowed to, I can try. I'll write this as 61 over 2. So h of t minus 3 equals negative 16 t squared plus 61 over 2t. And first I have to divide everything by negative 16 to use vertex form, which is negative h over t over 16 plus 3 over 16, which is equal to t squared plus or minus 32, 61 over 32t. So now I'm gonna add to both sides. So I'm gonna half this, and then that's gonna be negative 61 over 32t plus, what is that, 61 over 64 squared. And I'm gonna add 61 over 64 squared, right? Because I'm basically completing the square here, where I took half of this, which is half of negative 61 over 32. This is you divide by 2, multiplying by 1/2, it's negative 61 over 64, and you want to add that to both sides after you square it. So that's what we did here. And then you'll see that I'm going to pretty much, so I'm going to add this 4 times 4, 64, 12 over 64. Oh crap, but I have to square 64, 61. I'm not going to simplify it, but basically you're going to get this, okay? Let's see. So you're going to get t minus 61 over 64 squared. Yeah, you're going to get that 122 for 64, 61 over 32. Okay, and then you're going to get negative ht over 16 plus 12 over 64 plus 61 squared over 64 squared. So the vertex, the maximum height is, I'm going to subtract these over here. See guys, this is why it's not very, doesn't look nice to do it without a calculator. I'm going to multiply by 16 and take a negative. So it'll be negative 16. And then multiplying by negative 16, I'm going to get 12 times 16. Okay, so, right, because I multiplied by negative 16 to cancel here, this negative 1 over 16. So then I got that, which means the maximum height when t is 61 over 64 is, this goes to 0, it'll be this right here. So this is the maximum height, I believe. Now feel free to put that in your calculator. Yeah. So thank you guys so much for watching all of the videos I've made for 7th grade Algebra 1 and the rest of them if you would like. I hope you guys benefited from this. Thank you.